Ask a computer to write a heartfelt poem or paint a portrait of grief, and in seconds it assembles an expressive, moving piece of art. When we see those results, it is easy to assume the machine feels the sadness or inspiration it just created. But is it actually experiencing those emotions, or is it simply running a simulation? People and computers both take in information and produce answers. How they get from the question to the answer follows two entirely different sets of rules. On one side, we have our biological brains, which developed over millions of years to keep us safe. On the other side, we have artificial neural networks, which are built entirely out of mathematics and code. Figuring out exactly how a machine arrives at its answers helps us determine if these systems are going to replace us, or if they are highly capable tools we can use to do our jobs better. We can start by looking at the computer. This animated diagram shows what an artificial intelligence brain looks like. It operates as a massive 3D grid of interconnected points, entirely governed by math. To understand language, the system groups words together based on how often they show up next to each other in books and articles. It pulls related concepts together into clusters, putting the dot for rain right next to clouds and sadness. When you ask it a question, the machine does not pause to ponder the meaning of life. It calculates. A spark traces a path through those clusters to determine which word has the highest mathematical probability of coming next. The system has never felt a raindrop. It has never looked up at a gray sky. To the computer, those words are just numbers with high probability scores. So when a machine generates a beautiful story, it isn't having a flash of inspiration. It is winning a hyper-fast game of statistical prediction. Now, look at this animated diagram representing a human mind. Inside our heads, 86 billion pulsing cells form a dense, tangled network of neurons that behaves a lot like a wild jungle. Unlike a rigid computer grid, our jungle is constantly physically changing. When you touch a hot stove, or smell fresh bread, or learn to ride a bike, those biological branches actually reach out and grow new connections. Our memories and ideas are shaped by our heartbeat, our breathing, our physical need to stay safe, and our emotions. A computer links the word rain to clouds using a probability score. To us, that same word evokes the chill on our skin, the smell of wet pavement, and the quiet mood of a stormy afternoon. We learn by moving through the world with a physical body. We attach lived meaning to everything we encounter, which makes our way of thinking deeply biological. Because human beings have written down millions of pages about our feelings and experiences, computers have plenty of text to study. They can remix those words to output sentences that sound incredibly empathetic and creative. But consider this animated diagram of a closed room. If you slide a shape through a slot, and a machine inside uses a giant rulebook to find the exact correct shape to slide back out, it looks like the machine understands you. But it is entirely blind to the outside world. It just spits out the matching shape. Without real-world context, the machine gets confused by things humans grasp instantly. A computer reads that a chair has 4 wooden legs. If you show it a soft, round beanbag, it might not know it is a chair, because it has no concept of what it feels like to sit down. A computer does not have a sense of self. It does not possess personal goals, the urge to grow, or intrinsic motivation to explore. Because the machine only sorts symbols based on mathematical rules, it never touches the physical reality behind those symbols. It perfectly mimics the appearance of a thinking mind without ever actually experiencing a single thought. There is an ongoing debate about whether machines could ever reach the level where they can reason across any subject as well as a human, a goal often called artificial general intelligence. Many experts point out that true self-awareness requires biology and a drive to survive. Without those biological traits, piling on more sophisticated math will never magically cause a machine to wake up. Instead of worrying about a rival, we can look at what these systems actually offer us. They can process billions of data points in a fraction of a second, optimizing our work and recognizing patterns we would never spot on our own. We provide the perspective that data lacks. We apply moral reasoning, we ask the right questions, and we supply the real-world intent that guides the work. computers will continue to streamline our daily tasks and act as highly efficient assistants. But the messy, emotional human mind remains the only place where true meaning and purpose are actually created.